Who wasn't taught that gravity is what makes an apple fall? We've believed this for roughly 300 or 400 years, since Isaac Newton defined it and its relationship to mass. Well, in 2017, two neutron stars collided and proved, indeed, it's not a force. It's actually a distortion in space-time. According to Einstein, an apple falls from a tree because the apple's responding to a curvature of space-time caused by the planet's mass. There's no attractive force called gravity. Fair to say that's a massive paradigm shift. So, if we were wrong about gravity, could we be wrong about other theories, particularly those that involve it? How we measure Earth's mass. Today, the Cavendish experiment measures the mass of one object based on its tug to another. But even before the redefining of gravity, this theory had flaws. The gravitational conditions in a science lab are nothing like conditions in space, and the theory assumes that each particle exerts a fixed force upon all others, ruling out the very real possibility that particles near the surface of a planet might exert a force greater than those deep within it. So, if gravity is no longer a valid theory, and it's used to determine mass, and the mass of the Earth is overstated, then it follows that the masses of all other planets in the solar system are also overstated. If the Earth is cavernous or hollow, then so too is every other planet in the solar system. Some of the greatest scientific minds have challenged the theory of a dense Earth. Around the same time as Newton, geophysicist, mathematician, and astronomer Edmund Halley, who predicted the orbit of his comet, said the magnetic anomalies of the Earth could only be the result of a different composition. He believed that beneath the Earth's crust were two thick concentric shells, and that each region potentially had its own atmosphere, luminosity, and was possible